missed anything? So electrolysis and chemical cell exercise, the doubts. The first one is from page 17, question 12 and 30. So first thing, the diagram shows a cell. What is a cell? This is a device which produces electrical energy. The reaction in a cell is a redox reaction. Redox reaction means there is a loss and a gain of electron and involves electron transfer. We have inert electrodes are there. We have two solutions are there. One is iron 2 solution, another one is Br2. Complete the sentence. A cell will change dash energy to electrical. Which energy is there? So that is a chemical energy. So cell convert the chemical energy to electrical energy. A chemical reaction happen or occur and it produce electricity. And what about the movement of electrons? Whenever in a cell we draw the movement of electron, it is always from the negative electrode towards the positive electrode. So we have to draw in the next part, draw an arrow on the diagram to show the direction of electron flow. So what is the direction of electron flow? The direction of electron flow is always from the negative plate to the positive plate. In question 13, the second method is to make the steel article. The cathode is an electric, cathode in a circuit of electrolysis. Mark on the diagram the direction of electron flow. So how you represent in electrolysis, how you represent the electron flow? Like you have a battery or a cell. So from negative terminal of the supply, the electrons will move out. And towards the positive terminal of the supply, electrons are attracted. So if you want to show the movement of electrons in an electrolytic cell, it is from negative terminal of the supply towards the cathode, and it is from anode towards the positive terminal of the supply. But in a chemical cell, you show the electron transfer from the negative to positive. Is it clear? Page number 22. 22. Question? Okay. 22. This one? Complete the cell, complete the labels of cell 3. Okay. I'll do this question, because it is like all the parts are actually interrelated. So this question, in this question, you have the cell. As you can see, the first cell is made up of zinc and copper, a chemical cell. A chemical cell converts the chemical energy to electrical energy. So we have zinc is negative and copper is positive. So what this give an idea? In a chemical cell, the electrode which is negative, that is more reactive. So it means zinc is more reactive, and what is copper? Copper is less reactive. And how much is the difference in the reactivity? That is, we identify from the voltage. If it produces a high voltage, it means they have a greater difference in the reactivity. If it produces a low voltage, it means they have a small difference in the reactivity. So zinc and copper, which is more reactive? So it means zinc is more reactive and copper is less reactive. And how much is the difference in the reactivity? The difference in the reactivity is 1.1. So this will be 1.1. When you check zinc and nickel, so again, zinc is negative and nickel is positive. So what does give an idea? Because zinc is negative, so zinc is more reactive and the nickel is less reactive. So, and the difference in the reactivity is smaller. How you identify that they have a small difference in the reactivity? Because you can see 0.51. 0.51 is smaller value as compared to 1.1. So means between zinc and nickel, the difference in the reactivity is only 0.51. So they have a smaller difference in the reactivity. And how we identify zinc is more reactive, because zinc is having a negative, like zinc is a negative electrode here and nickel is a positive electrode. So in a chemical cell, the element which is a negative electrode, that is more reactive. So write an ionic equation for the zinc electrode, because zinc is more reactive. So the more reactive metal have a tendency to lose electron readily. So zinc will turn into zinc ion by loss of 2 electrons. And what is the order of the reactivity? We have zinc, we have nickel, and we have copper. Complete the labels in the cell 3, positive and negative. So I have copper, I have nickel. Which is more reactive? Nickel. So the one which is more reactive, I should put negative, and the one which is less reactive, I should put positive. Then what about the reading on the voltmeter? What will be the reading on the voltmeter? We want a reading from nickel to copper. If this total is 1.1 and this one is 0.51, so how much I'm left with? So it will be 1.1 how much? 0.59. So it will be 1.1, that's the total, minus 0.51. So I will left with 0.959. So we'll write here the voltage produced will be 0.59 volts. And because the nickel is more reactive, that's why it's a negative, where copper is less reactive, that's why it is positive. Is it clear, this question? Any doubt in this? Page 19, question 15, part 2B. Okay. So page 19, question 15. Part 2B. Two changes. What we can do here, two changes which would be needed in order to coat a nickel on an object. Here, we are doing a copper plating. Like anode is made up of copper, the electrolyte is a copper sulfate. So what happened, when the copper ions will move towards the cathode, the copper atom will go inside the solution as a copper ion. So there will be a copper plating. What we want a nickel plating. So if you want a layer of a nickel, then what anode should be made up of? The anode should be made up of nickel. So instead of copper, the anode should be made up of nickel. The cathode is an object which we are electroplating. Like example, say an object star we are electroplating. But what about the electrolyte or the solution? So the electrolyte should be nickel sulfate. Because what will happen? When the nickel ion will move towards the object, the nickel atom will go inside the solution as a nickel ion. So only thing, the changes, what are the two changes we have to make here? The anode should consist of nickel or anode made up of nickel, and the electrolyte should be a nickel sulfate. No, it's less reactive. So less reactive because nickel is less reactive, that's why too. So two changes which would be needed in order to coat a nickel on the object. So what changes we should make? The anode made up of nickel and the electrolyte should be nickel salt. Nickel sulfate, nickel nitrate, even nitrate, because all nitrates are soluble, so you can say nitrate. So during, if you want a electroplating, the electrode, the anode, and the solution both should be made up of same material. Any other question from this exercise? Page 24. Okay, page 25, question 20, and 24, 19b, 1 and 2. Okay. So the diagram shows a cell is there, a simple cell which is used. If a voltage is measured, you can see the more reactive metal is oxidized. Oxidized means it loses electron. And the bigger the difference in reactivity, the larger the reading. In a simple cell, using a nickel and a sulfur, the nickel is oxidized. What is the definition of oxidation? Oxidation is a loss of electron. You have doubt in B1 and 2. Use the data in the table to answer the following question. Which of the metals in the table is the most reactive? So they mention here, if the voltage measured is positive, then the metal 2 is more reactive. If the voltage measured is negative, then metal 1 is more reactive. So when we check beryllium and cobalt, we get a negative voltage. Which is more reactive, metal 1 or 2? If we check beryllium with cobalt, here we have beryllium and we have cobalt. We are getting a negative answer. If we get a negative answer, metal 1 is more reactive. So it means beryllium is more reactive than cobalt. Then we check beryllium with nickel. Beryllium is more reactive than nickel, and they have the same difference. You can see the voltage is 1.6, so it's 1.6. Beryllium and silver is not measured. Beryllium and vanadium is measured. So vanadium, it's only 0.7 and it's a negative. So it means vanadium is below beryllium. So what does give an idea? This give an idea that beryllium is more reactive than all other metals in this. Even when you check like cobalt and silver, the cobalt and silver, we are getting a negative answer 1.1. So it means silver is even below cobalt and nickel. That's why we are getting 1.1 in negative. As I mentioned, when the negative voltage is there, the metal 1 is more reactive. It's a positive voltage, then metal 2 is more reactive. So the question is, which of the metal is the most reactive in the series? So you will mention here beryllium. And why beryllium is the most reactive in this series? Because it produces a negative voltage when it is used in the cell. Like when it is used as a metal 1, it produces a negative voltage. Then state which two different metals have the same reactivity. So which two metals have the same reactivity? As you can see, when we did this, which two metals appear to have the same reactivity? Because the voltage produced by the nickel and the voltage produced by the cobalt is same with beryllium. So it means they have the reactivity of the cobalt and nickel is same because they are producing a same voltage with beryllium. Then predict the voltage by a simple cell with beryllium as a metal 1 and silver as metal 2. So how we can set up this? First, beryllium with cobalt. So beryllium and cobalt, and the negative voltage is there. It means beryllium is metal 1, it is more reactive. Nickel and cobalt, so it is more reactive when the voltage is 1.6. Then beryllium and silver is not measured, and beryllium and vanadium is measured, that is negative 0.7. It means beryllium is more reactive. This is 0.7. Then we measure a cobalt and a silver, which is minus 1.1. It means cobalt is more reactive, and this is 1.1. Now they are saying if we use beryllium as metal 1 and we use silver as metal 2, how much is the voltage produced? So what is the voltage produced? The voltage produced from beryllium to silver. So this value was 1.6. This value is 1.1. So what is the total from beryllium to silver? Because from beryllium to cobalt is 1.6. And from cobalt to silver is 1.1. So how much is the total? The total will be 2.7. And what about the value? Will be positive or negative? Because if metal 1 is more reactive, it must be negative. So what is the voltage produced or a reading on the voltmeter? We'll say it is minus 2.7. Why it's of 2 marks? 1 mark is for mentioning 2.7 and 1 mark is for the negative. Because I mentioned beryllium is metal 1 and silver is metal 2. So if metal 1 is more reactive than metal 2, it must produce a negative voltage, and how much voltage it produces, that depends on the difference in the reactivity of the two metals. So from beryllium to cobalt, it is 1.6, and from cobalt to silver, it was 1.1. So the total voltage will be equals to 2.7. Is it clear discussion? Then the last page 25. Question number 20. Okay. Copper to sulfate solution was electrolyzed using a carbon electrode. So carbon electrodes are the inert electrode. So what are the products here? We have a copper ion, we have sulfate ion, we have hydrogen ion and hydroxide ion. Copper ions are less reactive, so the copper ions will move towards the cathode, and sulfate, nitrate, and carbonates never move, so hydroxide ion will move there. And whenever hydroxide, like what is the equation for the copper ions? Copper ions gain 2 electrons from copper atom. And 4 hydroxide ions, they will lose 4 electrons. They will give oxygen molecules, they will give 2 water molecule and 4 E. So means the oxygen gas is there. So a gas was formed at anode. So what is this gas? This gas is oxygen. So whenever hydroxide ion move there, there will be oxygen gas. And you have to learn the test for the oxygen. We did in the class that if you want to test the oxygen, how we test oxygen? We test oxygen with a glowing splint. And what is the result of a glowing splint? It will relight. So glowing splint, relight. During electrolysis, electricity pass through copper to sulfate solution. Solid copper to sulfate does not conduct electricity. Explain both statements. So when we do electrolysis, copper to sulfate solution, solid does not conduct electricity. Why the solid does not conduct electricity, but the solution can? Because in copper to sulfate solution, first thing, how the marks are distributed, copper to sulfate is ionic compound. That's the first thing. That's the first mark. So copper to sulfate is an ionic compound. And what will happen in ionic compound, in aqueous, ions are free to move. Where in solid, ions can vibrate about the fixed position. So copper 2 sulfate is an ionic compound. In aqueous, ions are free to move, but in solid, ions can vibrate about the fixed position. That's why in solid, it cannot conduct electricity, but in aqueous, it can conduct electricity. Is it clear? This one? Any other question from this exercise? Any other question? So this was the exercise which was related to electrolysis in the chemical cell.